Hi friends! Today we're going to work on reducible second order differential equation with missing x. The first thing we need to do is use a p substitution. So we're going to substitute the first derivative of y, and this is also equivalent to dy dx. And then we're going to differentiate both sides because we also need that since we have it in our equation. So we have dp over dy over dx due to the chain rule. And that's equal to y double prime, or the second derivative of y. So the dx is a problem since the equation does not have any x's in them. But previously we see that p is equal to dy dx. So we can substitute that in. So we have dp over dy p, which is equal to y double prime. So we're going to go ahead and plug them in. So we have y times dp over dy p plus p squared equal to 0. Now we're going to try to put p on one side of the equation and y to the other side of the equation. So we're going to subtract p squared on both sides, and that will give us y over dp over dy p equal to negative p squared. We're going to multiply 1 over y times dy on both sides, which will cancel the y and dy. So we're going to do that. 1 over y dy. So both these will cancel out. So we end up with, we're going to put p in the front this time. So dp equal to negative p squared 1 over y dy. So we're going to divide p squared. So p cannot equal to 0. We need that limitations. So we're going to divide by p squared on both sides. And we end up with 1 over p dp equal to, so these are gone, negative 1 over y dy. So we can integrate both sides now, which is ln p is equal to negative ln y, absolute values of course, plus a constant. So we can move this negative to the as an exponent. So we got ln y negative 1 absolute value plus a constant ln p on the other side. Now we're gonna try to get rid of the ln on both sides. So we're gonna put e on both sides. As you can see, this is an exponent. When you're adding exponent, you multiply. So this is equivalent to e ln. Since this exponent negative 1 is equivalent to 1 over y, let's just do that now, times e to the constant. And the ln and e are eliminated, so it's just equal to p. As you can see, e and ln is also eliminated on the right side as well. Since e to the power of c is just a constant, we can make that into another constant. So we can make it into constant 2 over 1 over y is equal to p. So we have p on one side, so we could go ahead and substitute it back to the original, which is right here. So it's equal to dy dx. We have constant 2 over 1 over y. So we can multiply both sides with y, and we're gonna go ahead and move the dx to that side as well. So we're gonna do that. So we've got dx on both sides, and we're gonna multiply with y on both sides. Why not? And these are eliminated. So we got y dy equal to constant 2 dx. So we're gonna integrate both sides again. So we got y squared over 2 equal to constant 2 x plus another constant, which we're gonna put constant 3. So we're gonna multiply both sides by 2. These are eliminated. So we got y squared equal to 2. So we're gonna distribute it right now. So we got 2 times c2x plus 2 times c3. These are just arbitrary constants. So we could, traditionally, we just put a x plus b equal to y squared. And that is it. Please like and subscribe. It will help me a lot. Thank you, friends.